this is Pete Singer with Solid State Technology, and I'm here at SEMICON West 2017, and I'm in the Microtronic booth talking to the CEO, the founder, and the president, Reiner Fenske, and he's going to tell us a little bit about the company, first of all, and then we're going to get into the new product that he's got here. So, Reiner, could you tell us, when did you found the company?
Well, we've been around for quite a while. We started in 1994, actually.
Okay.
So,
and what was your goal when you started the company?
Well, basically, my original company I was with was Zeiss, Carl Zeiss, so it's kind of funny we do have a Zeiss microscope, getting back to its roots. And did a lot of semiconductor there for about 10 years. So what we wanted to do, I wanted to do, is to make something that we can address the need of specific requests from our customers. So that was really the niche that I was trying to do, is to try to do some type of inspection that would be tailored directly to the customer. And that's pretty much what we've done since then for the last 3 years.
Okay, great. And so the EAGLEview 5, which we have on display here, is one of the Best of West Award finalists, so congratulations on that. I understand you've got a lot of new technology, a lot of new algorithms in the tool with no loss in throughput. So I wondered, can you just tell us what the new capabilities are all about? Yeah.
Well, thank you very much. Yeah, we're very, very excited about being one of the Best of West. And yes, we do have something completely different, and we're excited about it. So the EAGLEview 5 basically was a project we were working on in the background for the last 3 years. And we kind of redeveloped the entire imaging type platform, the software that's associated with it, lighting, etc. So we've been able to bridge the gap from a macro perspective, if you look at it from a 1x type inspection, more towards the microscope realm. So the images are much brighter, there's much better color fidelity, there's much better resolution, we could find things that are much smaller. And what also happened, which was surprising, is that we're able to find less nuisance type defects or color variation type things. So although the resolution increased, we were also able to actually bring back or down some of that type of nonsense type defects.
Okay, so better signal to noise ratio?
Yeah, sure, signal to noise.
Okay. And what kind of defects are you typically looking for? Scratches, thumbprints?
Perfect. I mean, hopefully not too many thumbprints, but exactly that type of thing. Yes, we do have an edge algorithm, so we can find that. And any type of CMP or photo type defects, hot spots, yes, scratches, things of that nature. Typically, things that are about 1x that you can kind of see with a naked eye, but now starting to get more towards the microscope.
Okay. And this has 4 cassettes that would be running at all times.
Exactly.
Right? And you have a throughput of 3,000 wafers?
That's correct, and that's kind of exciting because we were able to keep the throughput the exact same, and we also were able to keep it as an upgrade possibility, so you don't have to buy a new tool. So you can upgrade this whole module with the software, the imaging, and all that as an extra piece. Okay. But you're right, there's 4 cassettes, so you just drop and go. You put down the cassette, it'll finish it up, it'll automatically go to the next one, and that continues indefinitely. There's no recipes needed, so you just put down the cassette, it reads the OCR, stores all the images, and everybody can just look at them from their desk.
Okay.
Yeah.
And it would automatically notify people if there was some unusual defect? Or
yes, certainly. By looking at the screen, you'd have a series of red and green icons on the wafer. So red, of course, means that it's different than what the reference wafer was. So that alerts the people to go ahead and look at it. And there's multiple monitors that are on the tool, so we're able to, you'll be able to see that from different areas of the fab.
Mm-hmm. Okay, anything else, Reiner, that we should cover today?
Well, I do appreciate having the interview, and I think we're good. Thank you.
Okay, thank you. Okay, now I'm talking to Errol Akomer, who is the Applications Director at Microtronic. And Errol, could you tell us just a little bit about what kind of defects you're looking for?
Yeah, we're looking for macro defects, hot spots, scratches, missing patterns, spin defects, those types of things.
Okay, and then you would go in and classify those defects, or how does that work once you're into the tool?
Yeah, our software, it's called Process Guard. It's a client, and we have unlimited licenses. You can run it anywhere in the fab or the enterprise, and you would classify the individual wafers manually, and from that you'll be able to do some root cause analysis and drill down to find common tools.
Okay, excellent. And could you show us just a little bit about how it works?
Yeah, here's some wafers that we ran on the show floor, and if we click on it, we can look at a wafer that was had some defects on it. The white circle there indicates that we've got a chip on the edge of the wafer. So in this case, if I zoom in on this spot here, I can see that there's an edge chip here. It's rather large. If I wanted to, I could make a measurement on this as well, just to see the size of it, and then move anywhere else on the wafer I'd like to go. Now, aside from that, we have an integrated defect library built into the software, and it's really good for training purposes, that type of thing. And so you can see different types of defects, like spin defects, just like this.
Okay, well, thank you, Errol.
Thank you.